Hello, everybody, and welcome to the pre-test for Exam 1. This test should give you a pretty good idea of the types of questions that you're going to encounter on our first exam. The first set of questions is going to come from the textbook, and so these questions, at least the page numbers associated with the questions and problems that are listed at the beginning, are using the current edition of the textbook, which is the 12th edition. So if these page numbers change, we want to use the same video, then with updated versions of the textbook, I'll try to post those new changes as we get them. But let's go to chapters, or page 24 through 28. That's going to be in the 12th edition of the textbook. That's going to be chapter 1. And so if you look at page 24, the first question that they ask about is number 10. And so if we go to, it's actually on page, 26 is on page 10. The statistical approach involved in generalizing from a sample of 25 patients to an entire population of hundreds of patients in a particular hospital is known as, and then you have A, description, B, decision-making, C, content analysis, D, an experiment, or E, secondary analysis. And the answer to this is, is also, by the way, you can check yourself on these if you go to behind the appendices. There's a list of chapters, and so for at least the problems in the textbook, you can go to the back of the book, check your answer. But the answer to this one, 10, is B, decision making. So we're trying to, again, the statistical approach involved in generalizing from a sample to an entire population is called decision making. And they cover that in the first chapter. Okay, question 11. A sociologist undertakes a series of studies to investigate various aspects of sports violence. For each of the following research situations, identify the research strategy, experiment, survey, content analysis, or participant observation, and the independent and dependent variables. And so, hold on just a second. I'm sorry, I think these questions, I'm looking at this now. Let's, these questions are off from this pretest, must be an old one. So let me update this and just go through the ones that I'd like you to know, which is the questions about, see if I can find them in the new edition of the textbook. 5 through 8. We'll actually look at, because I want you to know the difference between the levels of measurement. So I'll spend just a brief minute talking about those. Nominal data, just so you can hear it from me, is categorical data. So if we just have categories like eye color, hair color, political party affiliation, Republican, Democrat, Independent, those are categories of political party affiliation, eye color, brown, green, blue, these would be categories. We're not saying that somebody with blue eyes is better, worse, more or less than somebody with brown eyes. We're just saying that they're different, right? They're in categories. Race or ethnicity is a categorical variable. And so this would be nominal data. So ordinal data is ordered categories. So like socioeconomic status, if we don't have exact measured dollar amounts, then that if we just said like somebody has you could be in one of 3 categories: low SES, middle SES, high SES. Well, that would be ordinal data because there's order to those categories. Somebody with low SES has lower income than somebody in middle SES, and somebody of middle SES has less income than somebody in the high SES category. Also, sort of like if we had 3 people run a race and we recorded who finished first, second, and third, that would be ordinal data because first did better than second, second did better than third, but we might not know by how many seconds first beat second, second beat third, and so on if we don't record that data. Letter grade in a course is ordinal data. A did better than B, B did better than C, but how much better we don't know unless we record actual points. Then we have interval and ratio level data, and they are ordered categories with exact distances between them. So in interval data, there is no true 0 point to the data, to the range of data. So IQ, for instance, may be argued as a good example of interval data because even though we may know somebody with very low IQ, somebody has very high IQ, right? The person with low IQ doesn't have an IQ of 0. At least the way we calculate IQ, like according to the Stanford-Binet IQ test, it's your mental age over your chronological age times 100. So IQ would have to be some value other than 0. And so there is no existence of 0 in that data set. Sometimes people may argue that other variables, there is no such thing as 0, like height or weight. There is no such thing as 0 weight or 0 height, according to the way that those variables may be typically measured. Ratio level data is including a true 0 point. But my point, to interval and ratio level data is that we know exact distances between them. For instance, if somebody is 7 foot 6 inches tall and somebody else very tall, and somebody is 6 foot 9, we know exactly how many inches and feet they differ in height. If and ratio level data includes a true 0. So like number of hours that you worked in a given week. If you worked 0 hours, well, you say 0. If you work 1, 20, we can quantify that. And we know the exact measurable distances between those answers. Someone who worked 1 hour worked 1 more hour a week than someone who worked no hours, right? And so those are the levels of measurement. So the questions for this pretest, say someone who ranks a list of cities from slowest to fastest pace of life is operating at the blank level of measurement. So think about that. They rank a list of cities from slowest to fastest pace, right? So the cities are going to be ranked in order of pace, but we may not have exact measurable distances between those rankings. So we'd be dealing with ordered categories, right? Faster maybe than slower, but we don't have exact measurable distances, so this is ordinal data. So 5 is B. 6, a researcher who scores a set of respondents from 0 to 10 in terms of their degree of empathy for accident victims is working at the blank level of measurement. Well, they don't give us ratio, so there is a 0 in the scale, but because the scale is from 0 to 10, and we know exact distances between the numericals value of 0 to 1 to 2 all the way up to 10, then this would be an example of interval level data. So the answer is C. 7, actually the answer should be ratio level data, but it's not given. A social researcher ranks industries based on how much they contribute to a country's gross domestic product. What level of measurement is this considered? A nominal, B ordinal, or C interval. So how much they contribute to a country's gross domestic product, and they're being ranked. First, second, third. Well, again, there's order to those categories, but we don't know exact distances between, like how much do they contribute to their the GDP. So this would be another example of ordinal data, or B. And then I said 8, but I think those are the ones that deal with nominal, interval, ordinal, or nominal, ordinal, interval, and ratio level data. So 5 through 7, we'll just do those real quick. Okay, but to get into the calculations part of this pretest, I want to go ahead and just cover the different things that you're going to be asked to do on the pretest, so that number 1, you can complete the homework and turn it in, but 2, you're going to have an idea of what you might be asked to calculate on the exam. So let's go to the whiteboard, or the document camera, excuse me, and make sure we're displaying the appropriate screen. And the first question on the pretest asks, so given the following raw data, and so hopefully you have the pretest with you as we're going through this so you can see this for yourself. Well, here's the raw data. 1, 9, 2, no, sorry, 8, 8, 7, 5, 5, 5, 5, 3, 2, 8, 2, 1, 9, and 11. So there's the following data. It says, given the following raw data, construct a frequency distribution, right? We've done that. You've seen the video. We need an X column. We need an F column. Now, under the X's, we record all of the unique X's. And the following X's are unique. 11, and I'm going to go high to low down the page so that we can include a cumulative frequency column and a cumulative percent, which is also asked for. 11, 9, 8, 7, 5, 3, 2, and 1. Okay, and those are the unique values. And then how many 11s do we have in the data set? Well, just one, right? How many, right here, how many 9s do we have? 1, 2. How many 8s do we have? 1, 2, 3. How many 7s do we have? 1. How many 5s do we have? 1, 2, 3, 4. How many 3s do we have? 1. How many 2s do we have? 1, 2. And how many 1s do we have? 1, 2. Okay, and so our sum of F should equal the N. So sum of F equals N, which is equal to the total number of scores we have. So we had how many scores? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this number should equal 16 if we sum up the F's. 1 plus 2 is 3, plus 3 is 6, plus 1 is 7, plus 4 is 11, plus 1 is 12, plus 2 is 14, plus 2 is 16. So we've got all of our F's in. And we have our X's, so that is the frequency. When it says construct a frequency distribution, the X and F column is what I'm looking for, right? Now B, so this is part A, 1A, sorry. Part B is include a column of cumulative frequency for each score value. So 1B would be the cumulative frequency column. And since we've done high to low, this should work out to where the cumulative frequency, remember, is the number of cases at that level or below. So how many scored 11 or lower? Well, all 16 of them, right? Because 11 is the highest value that is reported in the data set. So we start with 16, we work our way down. How many scored 9 or lower? 16 minus 1 is 15, or we could count down. 2 plus 3 is 5, plus 1 is 6, plus 4 is 10, plus 1 is 11, plus 2 is 13, plus 2 is 15, right? So 15, 9 or lower. 8 or lower, well, 15 minus 2 is 13. How many at 7 or lower? 13 minus 3 is 10. How many at 5 or lower? 10 minus 1 is 9. How many at 3 or lower? 9 minus 4 is 5. How many at 2 or lower? 5 minus 1 is 4. And then how many at 1 or lower? Well, 1, there were just 2, right? And there's nobody below that, so the answer is just 2. And because we've listed them high to low, then the F column, the lowest number on the F column corresponds to the lowest number on our cumulative frequency column. So that's 1B. Okay, 1C now is to make a cumulative percent column for each score in the data set. So C percent is our column. And remember that cumulative percent is just cumulative frequency divided by N times 100. So we have our cumulative frequencies. We have our n of 16. And if we take cumulative frequency divided by n times 100, we get cumulative percent. So cumulative percent for the first value would be 16 over 16 times 100. And 16 over 16 is 1, times 100 is 100%. So that's why if you list them high to low, 100% would be your top cumulative frequency there. Then the next one, for what percentage of the data is 9 or lower, it's 15 over 16 times 100. 15 divided by 16 is 0.9375, and times 100 is 93.75. So you could do 93.75, or if you rounded to 94, then that would be fine. The next one, 13 over 16, right? What percentage scored an 8 or lower? Well, the cumulative frequency is 13. The n is 16, so 13 divided by 16 times 100. 13 divided by 16 is 0.8125. Times 100 is 81.25%. All right, what percentage scored a 7 or lower? 10 divided by 16 is 0.625, times 100 is 62.5%. I'm sorry, and these percentages are probably not necessary, but since I've been including them, I don't want to mark them out, but you don't have to include the percent since it's denoted up here in the top of the column. But 62.5%. Well, what percentage scored a 5 or lower? 9 over 16 is 50.5625, times 100 is 56.25%. Okay. What percentage scored a 3 or lower? 5 divided by 16 is 0.3125, times 100 is 31.25%. And then what percentage scored a 2 or lower? 4 divided by 16 is 0.25, times 100 is 25%. And then what percentage scored a 1 or lower? 2 divided by 16 is 0.125, times 100 is 12.5%. So there is our cumulative percentage column. All right, so we've done 1A, B, and C. Now D says, so 1D says, what percentage of the distribution scored 5 or lower? Okay, well, when it says 5 or lower, we're dealing with, well, first of all, it said what percentage. So we need a percentage or a cumulative percentage. But when it says 5 or lower, we need a cumulative percentage, right? Because 5 or lower. So we go to 5, right? And we look at the cumulative percentage. So over from 5 to the cumulative percent column, 56.25% scored a 5 or lower, right? So that would be our answer, 56.25%. All right, what proportion of the this is 1E. What proportion of the distribution scored a 5? Well, we didn't do proportion column because it didn't ask us to, but applying the formula for proportion, it's P is equal to F over N. The F for, and remember, they're talking about proportion of distribution scored 5. So we go to 5, we find the frequency F, 4, and we divide by N of 16. 4 divided by 16 is 0.25. So the proportion of the distribution that scored a 5 was 0.25. All right, now, what is the mode of the distribution? The mode is the most frequently occurring value. We can look at the 1A to the frequency distribution, and we can see that in the frequency column, 4 is the highest number. 4 is associated with 5, so 5 is the most frequently occurring value in this data set up here. So 1F, the mode, this would be unimodal, by the way, because there's just one mode, but the mode is 5, or you could just record the number 5. One thing to bring up as we talk about the upcoming test For homeworks, this will be the way it is this is the homework we're doing together, but we won't always do homeworks together. And I just want you to know that showing work like this, just putting 0.25 up here is fine if you get the right answer. But if you show your work and you happen to enter a number wrong in your calculator, you made a small math mistake, then I can give you partial points for shown work. If there are enough points. If it's just 1 point for the problem, it might be an all or none type of thing. But if there's enough points to that the problem is worth, and you show some work, even if you get the wrong answer, I can give you partial points for the setup. I can't do that if you just give me answers. So if you just give me an answer and the answer is wrong on the test, you lose all the points. If you show your work and the answer is wrong, you may get some partial points for the process, the setup. So just keep that in mind as we go through. There is no real work we can show with the mode. The median, we can show how we got it though. So 1G is determine the median. Well, let's put all these numbers in chronological order, and I'll just do this kind of down below 1G here. So we had 2 1s, we had 2 2s, we had 1 3, we had 4 5s, we had 1 7, we had 3 8s, we had 2 9s, and we had 1 11. So there's our data set in chronological order. And then when we find the median, we just count to the middle. Remember, the median is the middlemost score in the distribution. So we take 1 off the bottom, 1 off the top, and we do so until we get down to the middle. We're left with, this is an even data set, right? 16 numbers in the data set. So we're going to end up with 2 numbers left in the middle. Now, again, they happen like our example, our video leading up to the pretest. These 2 values are the same value. So we can just take the number. If they were different values, we'd have to average them to get the average value of the 2. But since they're both 5, let's just do the average for practice. 5 plus 5 divided by 2, that would be 10 over 2, which is just 5. So the median of the data set is also 5. Okay. Now, the 1H is what is the mean of the distribution. So let's look at that real quick. 1H, the formula for a mean is x bar is equal to sum of x over n. Right? And remember, with sum of x, we have to add up all raw scores. So if we take our frequency distribution x's and we add them up, we're going to be missing how many times the x's occurred, right? So we don't want to use the frequency distribution when we calculate the mean. We want to use the raw data. So we don't have to order these. They're ordered up above here, so I'm just going to put them in order so it's easier to make sure I got them all. This would be 1 plus 1 plus 2 plus 2 plus 3 plus 5 plus 5 plus 5 plus 5 plus 7 plus 8 plus 8 plus 8 plus 9 plus 9 plus 11. Sorry, I know this is so tiny, but all I'm doing is adding up all of the numbers in the data set. And then all of these are going to be divided by the n of 16. So if we add up all the numbers in this data set, we should get a total of 89. And if we take 89 and divide it by 16, we have our mean. And so our mean is 5.56 to 2 decimal places. So 5.56 is the answer to 1H. All right, so we've done all of 1. Now we can move on to 2. And number 2, they give us a kind of a setup for a problem. And they're going to ask us to calculate some things we've already calculated with number 1, but we're going to be asked to calculate some new things as well. A researcher interested in the effect of anxiety on concentration first arouses his subjects and then asks them to count backwards by 3s from 257. He counts the number of mistakes made in 2 minutes. The data are as follows. So this new sort of number 2, we look at our data set. We have a 12, an 11, a 10, a 21, a 3, a 0, a 2, a 25, a 9, and an 11. All right. So there are the number of mistakes made by these people when they, in 2 minutes, when they counted backwards by threes from 257. One person made 12 mistakes, the other 11. One person made 10, one 23. One person didn't make any mistakes, so pretty good job there. But what is the mode of this distribution? Well, let's look. We can put these in a frequency distribution. It might help us to determine the mode. But we can also just try to eyeball this since there's not much data here. If it helps you to put it in a frequency distribution, just do like we did in 1A. But let's say 12 occurs once, 11 occurs twice, 10 occurs once, 21 occurs once, 3 once, 0 once, 2 once, 25 once, and 9 once. So 11 is actually the only one that occurs multiple times in the data set. So the answer to 2A, what is the mode of this distribution? Again, it's a unimodal, and the mode is 11. Okay, so now what is the median of the distribution, 2B? Well, the median, we're going to record the value here, but let's go ahead and put all the numbers in chronological order out here next to the median. So the lowest number, I'm just going to go low to high again, 0, 2, sorry, should be a 2, 0, 2, 3, let's look, 9, so 0, 2, 3, 9, 10, 11, 11, 12, 21, and 25. Okay, so we got all the data in there. By the way, if we were interested, we could count how many scores, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we look like we have all the data. We count to the middle, 1, 1, off the bottom, off the top, off the bottom, off the top, off the bottom, off the top, off the bottom, off the top. And we're left with 2 numbers in the middle. Again, it's an even data set, so those 2 numbers, now that they're different numbers, they'll need to be averaged. So 10 plus 11 divided by 2, that's 21 divided by 2, or 10.5, right? So the median is 10.5 for this data set. Now, what is the mean of the distribution? 2C. That's x bar is equal to sum of x over n. The sum of the x's, we have 0 plus 2 plus 3 plus 9 plus 10 plus 11 plus 11 plus 12 plus 21 plus 25 divided by n of 10. If we add up 0, 2, 3, 9, 10, 11, 11, 12, 21, and 25, we get a sum of the x's, which is 104. And if we divide 104 by 10, we get our mean, 10.40. So our mean is 10.4. All right, then 2D, using the defining formula, what is the variance of this distribution? Okay, well, they're asking us to do variance before standard deviation. That's a little bit different than what we did in the video, but we should be able to accommodate no problem, just with the use of the formula sheet and also with our knowledge of how to set up the calculation for a defining formula. You pull in a new sheet. Okay, and I'll put up our existing data when I do the raw scores. So we're doing the same data set from number 2. The raw scores in the data set from sort of highest to low, we've got 25, 21, 12, 11, 11, 10, 9, 3, 2, and 0. And you have to include 0 because it actually is a valid data point. So, it will affect the overall size of the data, even though, a lot of the calculations with 0 will end up being 0. Okay, defining formula for a variance. Well, the variance is s squared, and the defining formula is the sum of x minus x bar squared over n. Right, without the square root, that's the formula we're trying to get to. Well, we need x minus x bar, then we need to square x minus x bar, then we need to sum it up, right? So the first column we need is x minus x bar. To get x bar, we look back, we just calculated in 2C, we calculated the mean, 10.4, so that's our x bar, right? So we already have it, 10.4. No need to calculate it again. What we're going to do is take each of these raw scores and we're going to subtract the mean. 25 minus 10.4 is a difference of 14.6. 21 minus 10.4 is a difference of 10.6. 12 minus 10.4 is a difference of 1.6. 11 minus 10.4 is a difference of 0.6. And we had 2 of those. 11 minus 10.4 is another 0.6. 10 minus 10.4. This time, remember, we're going to get a negative. This is going to be negative 0.4. 9 minus 10.4 is a negative 1.4. 3 minus 10.4 is a negative 7.4. 2 minus 10.4 is a negative 8.4. And 0 minus 10.4 is equal to a negative 10.4. All right, so if we were to sum up, just so we can remind you of this, sum of x minus x bar would just be adding up these deviations, right? If we add up 14.6, 10.6, 1.6, 0.6, 0.6, negative 0.4, negative 1.4, negative 7.4, negative 8.4, and negative 10.4, we will get 0. And we'll have no variability. So you can't just sum them up. You have to square them first. So x minus x bar squared is our next column. And we take our x minus x bar, the first one, 14.6, and we square it to get the answer x minus x bar squared. 14.6 squared is 213.16. All right, 10.6 squared is 112.36. 1.6 squared is 2.56. 0.6 squared is 0.36. And we had 2 of those. Negative 0.4 squared is a positive, sorry, 0.16. Negative 1.4 squared is 1.96. Negative 7.4 squared is 54.76. Negative 8.4 squared is 70.56. And the last one, negative 10.4 squared, is equal to 108.16. If we sum up this column, we will have sum of x minus x bar squared, which is the top number we need for our variance calculation. So this is the sum of the column, and if we add 213.16 down to 108.16, we should get a total of 564.40. So the variance is 564.40 divided by our n, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So this is just, we move the decimal place over. If we do the math, the variance is 56.44. So this would be, the whole setup for this is 2D. And that's our variance. Now it says using the calculating formula. What is the variance of the distribution? Well, if you're smart, and they ask you both on the test, of course you could just say that the answer is same, 56.44, because it would be. But let's go ahead and calculate this thing so we can see that it's the same. The formula, calculating formula for a variance is the sum of x squared over n minus x bar squared. Okay, sum of the x's squared, we could just, sort of for space on here, I guess what I'm going to do is, this is a separate calculation. Know that you wouldn't do this, you wouldn't have to do both on the test. But x's squared, we could just include a column. We have our x's up here, the raw scores. If we make a column for x's squared, then we'll get our sum of x squared at the bottom. So 25 squared, this is 625. 21 squared is 441. 12 squared, 144. 11 squared, 121, and we have two of those. 10 squared is 100. 9 squared is 81. 3 squared is 9. 2 squared is 4. And 0 squared is 0. So if we sum up this column, we get the sum of x squared, which is sum of x squared is the number we need for our calculating formula variance. So we add up 625 down to 0, and the total we get here should be 1,646. So you take 1,646, we're going to divide it by the n of 10, and we're going to subtract out the mean squared. Now remember, the mean we calculated before in 2C. I'm going to pull it back here to show you that our mean x bar is 10.4. So when we need the mean squared, we need to square 10.4. So we're going to put in minus 10.4 squared. Okay. This is going to be equal to 1646 divided by 10, or 1,646 divided by 10 is 164.6 minus 10.4 squared. 10.4 squared is 108.16. And the difference between 164.6 and 108.16 is 56.44. So either way you do it, your variance is 56.44. Now 2F, they're going to say, what is the standard deviation of the distribution? Okay, well, if we have our variance, if we know S squared, then S, standard deviation, is just equal to the square root of our variance, right? Because remember I said pull the number out from underneath the square root and you have your variance. Well, the S squared we calculated up here is 56.44. So if we take the square root of that, we'll have our standard deviation. So 56.44, take the square root, and the square root of 56.44 to 2 decimal places is 7.51. So the standard deviation is 7.51. And that's 2. for the practice test. Number 2, rather. All right, so let's go on to 3. In 3, now 3, by the way, I'm just going to show you how to do this because this will help you to complete the pretest, but this is not something that you're going to see on the actual test. Because, you know, this involves way too many numbers for us to really, you know, kind of be able to use the methods that we talked about. Okay, so 3 is after a 10-minute meditation, students are asked to indicate on a 1 to 7 Likert scale how relaxed they feel, with higher numbers indicating more relaxation. Okay, and so the data that they present to us in 3 is the score that they got. And this is on a 1 to 7 scale, so 7, 6, 5, just highest to lowest, 4, 3, 2, and 1. That's the possible range of scores, and then the frequency they're going to give us as well. And I'm doing this opposite, I realize, of what it's printed in the pretest, but I'm just reversing them to put the high number at the top. Frequency for 7 was 25. For 6 is 15. For 5 is 10. And for 4 is 7. For 3 is 2. And for 2 is 1, and 1 is 1. So 25 people indicated a score of 7, 15 people a score of 6, 10 a score of 5, and so on. And then they say in 3A, they want us to find the mode of this data set. Well, mode is easy because it's the most frequently occurring value. If we look at the frequency distribution, 25 is the highest number. It's associated with a score of 7. So the mode, again, we have a unimodal distribution, and the mode is 7. 3B, what is the mean of this data set? Well, mean is equal to the sum of the x's over n. Well, we have to, because there were 25 7s given, we'd have to take 7 and add it together 25 times. Or we can apply a different formula, which I think is on the formula sheet. But there's a reason I'm not going to ask you to calculate the mean using this other formula. It's the sum of x times f over the sum of f or n. So here you're just taking and multiplying 7 times 25 first before you add them all up. So if we got an x times f column, then it would be 7 times 25, which, hold on just one second. Seven times 25 is 175. 15 times, or sorry, 6 times 15. 6 times 15 is 90. 5 times 10 is 50. 4 times 7 is 28. 3 times 2 is 6. 2 times 1 is 2, and 1 times 1 is 1. If we take the sum of this column, it's sum of x times f. So 175 plus 90 plus 50 plus 28 plus 6 plus 2 plus 1 gives us 352. And that would be if you added up 25 sevens, 15 sixes, 10 fives, and so on, you'd get that total using the other formula that we've been working with the whole time. So the sum of x is 352 divided by n, which the n is the total frequency here. So n is the same thing as sum of f, right? Sum of f, sorry, this looks like a bad sigma. Sigma f is equal to n. So that's 25 plus 15 plus 10 plus 7 plus 2 plus 1, which is 61. And so 352 divided by 61 gives us our mean. That's 5.77. So our mean is 5.77. Again, because this is involving sort of formulas we haven't really spent any time talking about, you can see how we're not going to be asked to do number 3 on the exam. Number C, or letter C, 3C, is find the median for this data set. So 3C, we could use our method and list out 1s to 7s, but we'd have 25 7s to list out. And so there's a formula a little bit, not really to give you the median, but it's called position of median. And the formula is n plus 1 divided by 2. Now our n is, so n plus 1 divided by 2. And this just tells you where to look for the median. So n is 61 plus 1 divided by 2. That's 62. Sorry. 62 divided by 2. So the position of median, where it says to look for it, is the 31st number. If we count to the middle, if we put all the numbers out in chronological order, we count to the middle, it would be the 31st value, would be the median. And it's an odd data set, so it would be the 31st value. Well, a simple way to do this would be 25 of the values on the high end of the scale are 7s. So if we take out all the 7s, we've only counted for 25 of this 31 numbers. But 25, if you take 31 then and subtract those 25 7s, you end up with 6 more scores before you find the median, like it's the 6th score in. Well, you're not going to get through the 6s before you get 6 units in, right? Because there's 15 6s. So because they're all 6s, you're going to count off another 5 6s, and then the 6th 6 that you come to is going to be the median. So the position of median tells us it's the 31st value in the middle of this 61 numbers. But the long and short of it is that the median is equal to 6. Because we could count from the bottom. It's harder to do it that way. It's easier to come from the top, take 25 off of 31, and then take off another 6, and we'd still be in the 6th category. So 6 is the median. But again, not going to have to do that on the test. Now, D, 3D. Draw a pie chart of the data. Now, you can do this. A pie is just, a circular chart of the data. And I like to use percentages. Because I think of the whole pie as 100%. And so if I draw my circle, right here, not a very great one, but if I draw my circle and we see, well, what percentage of the data is 7? Well, 25 of the scores out of 61 are 7s. So that's 0.4098 times 100 is 40.98%, or 41% of this pie is 7s. So it's not quite half, right? But it's a fairly big portion of the, let's say maybe 40%. And I'm not going to draw this accurate. There's no way. But let's say that's 7s, right? The 6s, well, how many 6s were there? There are 15 out of 61 of those values are 6s. That's 0.2459 times 100 is 24.59%. So about 25%. So about a quarter of the data. If we want to think about this being, it would have been easier to do a quarter some other way, but here we have the whole thing is drawn into a quarter. Let's just say it's roughly about like this. That's not even close, but 6, it would be a quarter of the data, okay? Then 5 is 10 values out of 61, or 0.1639 times 100 is 16.39, about 16%. So it's a little under 25%. Let's just go a little something that's kind of smaller than that. Maybe something like that. Call those 5s. And then 4s. There were 7 out of 61, which is 0.1148, so 11.48%, about 12%. And so again, maybe something smaller than 16, but not by much. Maybe something like that is the 4s. The 3s, There were 2 out of 61. These become very tiny. That's 3.28%. So again, maybe just something like that is the 3s. And then each of the 2s and 1s, there was just 1 out of 61, which is like 1.64%. So we'll just kind of split those evenly, 1 and 2. And so that's kind of the pie chart of the data. It's not perfect, but that'd be what we'd do. We either use frequencies or percents. Again, not something you have to do for the data, but something you might kind of copy for the homework. 3E is draw a cumulative histogram, which they call of the data, which is histogram is a distribution. If you looked at chapter that talks about visualizing the data, histogram is a set of connected bars to indicate continuity in the data. This is a continuous scale from 1 to 7. Again, because it's cumulative histogram, you can do percentages or frequencies. It doesn't matter. I'm going to do in terms of percent. So from 0 to 100%. If we did cumulative frequencies, then 7 would be 100%, right? So if we go from the value of 1, 2, 3, 4, 5, 6, and 7, 7 goes all the way up to 100. There's our bar for 7. 6 is going to be a bar that touches 7, and it's a 6 is in terms of cumulative frequency is we'd have to add up these numbers, but it's 15 plus 10. That's everything. It's 61 minus 25, which is 36. So 36 out of 61 is 59.02%. So about half, a little over half of the data is 6. So there's our bar for 6, a little fatter, I'm sorry, than 7. 5 is, you don't have to, the way we work these is it's all but 40 numbers out of 61. So 61 minus 40, that's the 25 and 15 that we're excluding for 7 and 6. That's 21 out of 61. That's 34.43% of the data. So about a third. So we go up about a third. This is our 5s. And then a 4's, 18.03% is what it works out to be. It's about half of that bar. That's the 5s. So here's our 4. 3's, 6.56%, so about a third of this bar. Here's your 3's. And then 3.28% is the 2's. That's about half of that bar again, is your 2's. And then about half of this bar, because it's 1.64%, it's about half of that bar is the 1. So about right there. So there's our cumulative frequency distribution for this data set. Like I said, maybe copy down 3D, 3E, all of 3. Just understand you don't really have to do that on the exam. Okay, 4 is the final thing, crosstabs. And remember, here's our setup, freshman. So I'm just going to put fresh, soph, junior, and senior. Right? And then we have law majors. So I'm just going to put law and medicine. And they have 20 freshman law majors, 15 sophomore law majors, 25 junior law majors, and 30 senior law majors. Then for medicine majors, there's 10 freshmen, 20 sophomores, 80 juniors, and 25 seniors. Okay. So we get our column totals, 20 plus 15 plus 25 plus 30 is a column total of 90. 10 medicine majors, 10 plus 20 plus 80 plus 25 is 135. And then our row totals, 20 plus 10 is 30 freshmen. 15 plus 20 is 35 sophomores. 25 plus 80 is 105 juniors. And 30 plus 25 is 55 seniors. We get our grand total. We can add 90 and 135. If we do that, we're going to get 225. Or we can add 30, 35, 105, and 55. We still get 225 total people. Okay, now the questions are for A, what percentage of medicine majors who study more than 30 hours per week are freshmen? And so, the setup is the same. It says law and medicine majors are asked to report the average number of hours spent studying per week. The number of students who study more than 30 hours per week are recorded for each category. The following cross-tabulation presents the data. What percentage of med majors who study more than 30 hours per week are freshmen? We take out them who study more than 30 hours per week. It's what percentage of medicine majors are freshmen? So percent is equal to F over N times 100. The F for us is the number of medicine majors. That's 135. That goes under, I'm sorry, the N is medicine majors. That's 135 total medicine majors. What percentage of those are freshmen? We look at the medicine major out of 135 totals, 10 are freshmen. So 10 over 135 times 100 will give us our answer. 10 over 135 is 0.0741 times 100 equals 7.41%. Right? Now, for B, what percentage of students who study more than 30 hours per week are juniors? So what percentage of students are juniors? Well, percentage is equal to frequency over N times 100. That N is how many total students, 225, right? And then how many of those total students are juniors? Well, there are 105 juniors out of 225 total students. We're looking for percentage, so we multiply the constant of 100. 105 divided by 225 is 0.4667 times 100 is 46.67%. And then the last one, 4C, is, and let me flip this over so we don't get confused on our numbers. What percentage of students who study more than 30 hours per week are law majors? So students, how many of students are law majors? What percentage? F over N times 100. Again, the N is total number of students, 225. The F is how many of them are law majors? Well, there are 90 law majors out of 225 students times 100. Well, 90 over 225 is 0.4 times 100 equals 40%. And that's how you do crosstabs. So, likely on the exam, you're going to run into questions like question 1, maybe some multiple choice questions about the levels of measurement, and some other conceptual questions about central tendency and variability, which you should get from reading your textbook and understanding the concepts that are talked about there. For calculations, you'll likely see something that looks very similar to question 1, question 2, and question 4 on the exam. You won't see something that looks like 3. So thank you, and good luck studying.